that being said, let's introduce our speaker today, and that is Dr. Diana Schwaha. So Dr. Diana Schwaha, she is the chair of Computer, Electrical, and Industrial and Systems Engineering, and also professor of Industrial and System Engineering in Liberty University. She currently serves as the chair of the Computer, Electrical, and Industrial and System Engineering at Liberty University. Prior to coming to Liberty, she served for nearly 15 years at Ohio University and also worked for the National Institute for Occupational Safety and Health. So as I mentioned, she'll be talking on integrating safety with process improvement strategies and techniques. So with that being said, I want to welcome you and hand over things to you. Thank you.
Thanks, Ogaga. I'm going to share my screen and go into my presentation. Oops, yeah, there we go. All right. Ogaga, can you see this now?
Yes.
Okay. I'm actually going to talk a little bit about two areas of research. A lot of it will be on integrating safety with process improvement, but I'm also going to talk a little bit about exoskeletons, basically the two types of research I've done lately. And I just wanted to say I would love to be meeting you all in person. It would be a lot more fun. So maybe someday we can come down. I can bring the students down for a tour or a trip. I think they would probably love that. But to give you a little bit about my background, you already heard that I used to work at NIOSH, but I came to Liberty in January of 2021. But before that, I served I sort of went up the ranks, but I was a professor when I left in industrial and systems engineering at Ohio University in Athens, Ohio. I came down here to build the industrial and systems engineering department, and been down here almost 2 years. It doesn't seem possible that time has gone so fast. What I'm going to speak about today is mostly some of the work that we did at Ohio, because I've been involved in a lot of administration here right now. But I do have 2 PhD students, so I'm getting back to my research. My main areas are ergonomics and quality. I'm a trained Six Sigma black belt, but I've also been teaching facilities and forecasting, and one of my PhD students is working on a nuclear energy project. She's interested in looking at risk with that. So that's sort of what I do. I don't know what everyone's background is. ASSP has a really broad scope of what your expertise could be. I'm going to start out with just a little bit about human factors engineering, because it is also a very broad area, but the definition that I use and have used for years in all my classes is that it's a discipline dedicated to studying compatibility between people and other people, products, and processes to improve safety, productivity, and user satisfaction. It really is. I mean, everything by the time you get up until you go to bed, you are working with something, some person, another person, products, or processes that a human factors engineer has helped develop. And I know especially today, I want to say post-COVID, but even pre-COVID, a lot of the processes, because we are so overstressed, people are working more with less resources, fewer resources. Improving those processes is really key. And also to keeping them safe, especially when you don't have other people, you have no bench of employees. In human factors, it's again really broad, which is I think sometimes people, if you're out of the field, don't realize. Most people just think about it, okay, it's physical ergonomics. It's like that lifting, or vibration, or noise, or heat. And we think about fit or clearance, layout, manual materials handling. That's tool design. That's one area that a lot of people work at. And when we think about injuries, if you're a safety professional, I mean, that could be a cause, one of the major reasons for a cause that you may have an injury. But there's also cognitive ergonomics, which is information processing, decision-making and stress, and interface design. Organizational ergonomics, which has to do with attitudes, motivation, team design, teamwork, teaming, motivation, I would say. I already said that. That's a big one right now. And then systems ergonomics. So integrating systems across teams. And that's also another one. I mean, a lot of times people think systems integration, they're thinking about databases, but think about systems like you work for a company and you get bought out by another company and their way that they do it is totally different. So you're trying to integrate these two processes and cultures. So it can be really different. I know you're professionals, but these are some of the characteristics that I always like to state about human factors. We're really committed to the ideas that machines are built to serve people, not the other way around. A lot of times we're dealing with machines or objects or different types of tangible things in the workplace, and they are just not designed for people. So we'd like to have it the other way around. We're really front-end types of people. We want to be proactively involved if possible. We recognize individual differences. We have a conviction that design influences human behavior, right? So, there's been so much in the safety world about, why people get hurt, and, human behavior is always at the top, but we tend to think we like to do process over person. We like to think about the process. We like to think about how that's designed is really going to influence that behavior. Even if you get, an outcome that you don't love in terms of the behavior, there was something in there that could have been mediated by a better design. Emphasis on empirical data. It's not just common sense. Good ergo is good economics. For our experiments, we rely on the scientific method. And we consider the world holistically and individualistically. So we know that for systems, we have to think about the micro and the macro. We have to think about the individual, that one person, and also how every one of those people working together make the system go. In terms of physical ergonomics, I brought in, these have just some, if you want these citations, these were some slides that were taken out of a previous presentation. But when we're thinking ergo, I know safety is usually, like when we think about injuries, we think about acute safety is acute injuries where something happens right away, versus ergo is chronic, and it includes soft tissues. So work-related musculoskeletal disorders or overuse injuries, there's lots of different words for them, but they impact soft tissues like joints, tendons, muscles, nerves, ligaments. They occur over time, so they're chronic. They develop from overuse, and they have very high costs, and in some cases like backs, they have high recurrence rates. So we want to be proactive, because if you prevent one, you're not only preventing that one injury, but you're likely to prevent a lot more in the future. They can have psychological and physical, like someone's psychological state can contribute to whether or not they return to work, or how they're feeling at work, or how they respond at work. So we do have to recognize that. That's a little bit old. The next one is the cost, but they have a huge cost in direct and indirect costs every year. Most of you probably have seen those iceberg. I didn't include that in here, but those iceberg diagrams. And what people tend to see in direct costs, like above the water, is just really a small piece of it. There's all the indirect costs that go into when someone's hurt, that companies incur. But they are mitigable. So, the thing is, we can prevent them, and we need to prevent them by anticipating what can go on. So in general ways, okay, and so this talk is, I know it's going to focus on working in systems, but I really wanted to share with you just a general outlook on how I think about things. So we always, according to the hierarchy, would like to eliminate the risk, right? So if I have some kind of really horrible lifting task, and I'd like to just eliminate it so the person doesn't have to do it. If I can't eliminate it, then I want to modify the workstation somehow. And by modifying the workstation, I am, again, putting the responsibility on the process, not the person. And if I modify the workstation, there's a much higher likelihood that a variety of different people with different abilities can work safer. If I can't do that, and let me give you some examples. I'm on a construction site laying bricks. I'm putting down carpet. I'm on a construction comes to mind because it's just so not standard. Then I want to think about how I can assist the employee. And so I'm going to talk today about a systems approach with this one spreadsheet. I'll show you how our systems, this project we had on integrating safety with process improvement. But then I also want to talk a little bit about exoskeletons too, because I don't know how familiar everyone is with them, and they're still very much they're being used, they're being developed. I think there's still a lot that needs to be done with them, but I wanted to share a little bit about them in case you might be with a company who has considered, or maybe you already are using exoskeletons. So I'm going to start first and talk about them and then go into the other piece. So, and this is just what I talked about. I've done some education work. So these are some sort of funny pictures. It's sort of funny, but actually we've come full range here. These are sci-fi, you know, where you see someone all, I would say powered up with these exoskeletons ready to take on the world. It's actually how the original ones, this is the Hardy Man from the mid 20th century. This is, you know, these are real pictures, and just to see how they could augment. Of course, this looks completely undoable, unsustainable. It was like more of a proof of concept thing. The full circle thing is I'm going to talk about passive exoskeletons, which are non-powered, but there is research on powered exoskeletons too. Very expensive, so probably not doable. The exoskeletons that are doable are being used for a variety of reasons. One is rehab. So in terms of exoskeletons, and you can see this one is powered, helping people to walk, come back from injuries in a clinical sense. That is completely not my world, so I don't do anything with that. Or in this case, a hand exoskeleton for work. This is a tool assist exo. I've actually had this on. This is actually, I didn't really like this one because it was very, I felt very unstable having it on because it's just clunky and walking, but this is a tool assist. And then arm support exoskeletons, and I'll show you there's a back support exoskeletons too. So right now, what I would say is the ones that are really being used are passive, they're non-powered occupational exoskeletons for industry, mostly arm support, what we see down here, and some back support. And there's thumb support too, I'll show you in a second. But so that's what we're talking about, passive occupational. These are technologies that can help you. They are not powered. They have springs in them. The different manufacturers all have different designs. The thing about any kind of system that has a spring, imagine you can imagine a spring. In certain positions, they will support you, like support your arms, but in other positions, you have to put force against them to move, you know, so they may spring your arm up to hold your arms up while you're working, but if they're activated and you want to put your arms down, you have to apply pressure. Most of them are really easy to turn off and on, so if you are not working with something, you just turn them off and your arms hang back down, but they are to provide strength augmentation. They're well adapted for repetitive processes, but I'm gonna put just a little, if you're thinking about using them, if you ever want to just call and chat about these, I can share more in detail what we did. But in our research, we actually found they were a little bit better for static. Like imagine you're holding a paint gun or you're working on an assembly line with your arms above your head. If it's very repetitive and depending on how far you're moving, like the angles through which you're moving, if you are, like I said, because they're spring-based, if you're moving through a significant range of motion, then at some point it's helping you, but at some point you're pushing back on it. And so that comes into play. Let's just say that comes into play, I think. There's just a lot right now. Initially, the work was, do they actually work? And the questions are, yes, they reduce through EMG muscle activation. But most of the research now is like, okay, so what do they work for? Which tasks do they work for? Things like that. And they're being tested. They're being used. Toyota, the autos are using them to a great extent. I know the last I heard, which is about 6 months or a year ago, Toyota was using them. What they would do is they would say, okay, I have a job. I believe this job needs the help of an exo. We're not going to tell the employee which exo. We're going to provide a variety of exos. The employee can try them on and choose the one he or she would like to wear. But you know, that's sort of their approach. The last I heard what they were doing with exos, they're about 5,000 a piece. So they're just expensive for, they're expensive for a lot of companies. I mean, when we went out, I had a 2-year study with them in Ohio, and there was really only one company that we worked with that didn't really blink at the cost. And that was because they had really not tasks that really weren't able to be standardized, or like some intervention put in, and they had injury costs. Okay, so one of these pictures you've seen before, but let me just go around. So these are the basic types. This is a little, and I'm not, I just want to say, I am not going to advocate for a certain brand. I'm showing you things. Some of these I have, or I've tried on. Actually, I've dealt with all of these, except I've never actually tried a thumb exo. But Pexo is a company. Autoblock is a company that's been around for a long time, and they have exos, a variety of them, but they have this thumb exo. So if you have certain processes that are a lot of that pushing, this is called the chairless chair, Noonie. Interesting concept. Kind of, it was hard for, I've had this on, it was kind of a little unstable, but you know, if you have a place where people are walking a lot and they have different levels of jobs, so like at some point they might be standing, and then at another point they're like more like sitting, you can just walk around with this chair and you just sit down and it locks on you. This is a tool holding Fortis, it's called a Fortis. This is again, another PayExo. There's a lot of different brands. Actually, if you're interested in this, the best place to go to is a website called exoskeletonreport.com, and they just have all the different brands in there and articles. But this is a arm support. So arm support, basically you wear them like a backpack. They hook to your arms. They have some kind of spring. So in this case, this is where the spring lever is in this, and they hold your arms up. They have a different design than, like there's a Levitate that I've used, and ExoVest that I've used, and we have one of these in the lab. So, but they're not, they can range anywhere from like 3 to 7 pounds. They're not super heavy. And then this is a picture, a little bit unclear, way it blew up, but it's a back support exoskeleton. So back supports are basically, if you can see this right here, they have some kind of strap around your thigh. They have a waist strap, and they have something around your chest. The spring, the support is right here on the side of your hips. So basically when you flex, if you can imagine this person flexing over, the leg support sort of blocks, and there's a spring to support this either chest or on your back support. So it sort of limits your flexion. That's how they work. We have tested, I had one of these, but we actually just ended up testing arm support. They're not to make the person work harder, okay? They're just to decrease the task demands. And there have been some studies, like there was a study with Lincoln Electric on welding, that they had the potential to increase quality, presumably through a reduction in fatigue. So one of the things when we were out, that the employees were always like, oh, you just want us to work harder? We're like, no, that is not the point of these. The point of these is like, instead of having an intervention on the job, the intervention is on the person. And that being said, there's been a lot, it's been sort of bantered around too, is whether or not exoskeletons are PPE, and I do not consider them PPE because they do not really block the hazard. They help you, but the extent to which they help you is going to differ depending on the person. If you have them adjusted the wrong way, I mean, adjustments are really key. So you're going to have a difference in the level of support if they're not adjusted the right way. I don't feel like that's an appropriate word to use with them. myself. So, okay. Just to give you a sense of the kind of research that's going on, if you're curious about using these, and our research was mostly focused on the wearability, and then we did some machine learning with whether or not a person would likely to wear one, given we did research in the field. But so the wearability of them, they're, the heat factor, the weight of them, limitations of movements. They, like I said, they weigh between 3 and 7 pounds. So basically you have to have a bigger benefit than wearing the weight of them to make them worth it. And they do get hot, and they are recommended to buy one for each person. Cause they have pads, and usually they have some kind of like padded, I don't know, like neoprene or something, but they get sweaty and dirty just like anything else you'd have on. So they're really for, like, you don't want to buy one for the team. You want to buy one for each person. And they're about $5K a piece. There's been a lot of studies on decrease in muscle exertion, and this is shown through surface electromyography, just kind of looking at a percentage of max, like, okay, you do the task without one and you do one with one, and you look at what's the different percent compared to your max of each task to give you a sense of like what's the reduction in EMG based on that. So there's been a lot of work on that. There's been work in different kinds of tasks. Some of the questions that have come up is, are there increases in other muscle exertion? The main reason, well, a lot of people had this question. There was an article by a professor in Ohio, wasn't me, who had a study that showed that it did kind of like, there was a trade-off that while you relieved the stress on one muscle group, it went to another group. There's been a lot of other ones that say it doesn't. So that's kind of that question. I would say, does it really? No, not really. But you are going to find, if you go search the literature, you'll find articles on both sides. Interestingly, there's been some more work on cognitive load, like what's the effect on one's cognitive load based on the EXO. And then, like I said, you have to have a greater benefit. You have to get over the fact that you're wearing this thing that's like 3 to 7 pounds. So your benefit from wearing it has to be better than that cost of wearing it. And depending on the person, you have a really big person, it's not a big deal. You have a smaller person, doesn't weigh as much, maybe comes into play. I think some of my own work, and this is, again, like if anyone's interested in this, please reach out to me. Low cost exos, because I think the cost is high, and they're not really like, they can break, they're giving you, usually they give a 1-year warranty on them, but okay, so that's $5K, then you're talking $5K a year for each employee. So I think it would be great to have some lower cost. I have a student right now working on incorporating exos into digital twins for manufacturing using Simio, just to kind of have a better way of looking at how do I cost justify this, and then maybe using smarter fabrics. I just want to talk about that. I know this talk is more about process improvement, but the exos is kind of people tend to be a little bit interested just to see what's happening with them. Okay, so let me just introduce this topic. So both the EXO and the process improvement were studies that I did that resulted from a grant from the Ohio Bureau of Workers' Compensation. And just if you don't know, every year they have a spring expo conference, whatever you want to call it. It's always in March. It's free. It's awesome. It's all volunteer. So all the speakers are volunteer. The committees are all volunteer. They have a huge vendor, like the vendor room with all the people. So it's just really fun. I know that some of you, it may be kind of far for some of you, but if you're up in that area, it's worth going to. Considering the cost of other conferences, I think it's really worth going to. But that's how I got these grants for these. So one of their interests was, how do you integrate safety ergonomics into process improvement? And it's an evolving methodology. People have different tools that they use. There's these nodes, like when you say process improvement, you may just think continuous improvement. You may think continuous process improvement. You may think Six Sigma. You may think Lean. You may think Lean Six Sigma. A lot of times leaning processes, you can actually lean out so much of the process that there's actually more repetitive motions. So there's been some research to show that you have to be careful, like in terms of lean, just using lean, because you have to consider the person in that equation. And a lot of times, from what we started this project by just talking to a lot of industry safety and supervisors. They were all in manufacturing, and they would tell us these stories about, okay, well, we did this great lean project, but then we didn't realize there was some human aspect that they forgot about. So, the idea behind this whole project was, how do we integrate safety with quality, with productivity? How do we develop a system where you look at them all together and come out with better outcomes? So I'll eventually get to the webpage. This is all, again, this is from Ohio University, where I used to be, but all these materials are free and are on the web. Just have some slides a little bit about this. So these are just some, these authors have written a lot on this, but ergonomic interventions, productivity increases with ergonomic interventions, and hours needed to complete the job decrease. So these are not like, safety is not an isolated silo, right? Everything that you do in safety affects something else, and everything that is done somewhere else affects safety. And so the thought of like the safety person coming in at the end and just saying, hey, can you check this box to say that you approved it, is not the best idea. You end up with a lot more costs. There's quality standards that need to evaluate the ergonomics as better improvement. Ergonomic implementations, quality defects decreased by 30%. These are just some data to show you that there is literature out there on studies. My guess is that all of you have your own data, but it's not all published. So there is definitely a relationship. There's definitely literature that shows that there's a relationship between ergonomics, quality, ergonomics/safety, quality, and productivity. And then the other thing about this is that there's this notion of safety culture, which is not part of this project. But it's also this notion of, if we think together and we think alike and we integrate these ideas, we're kind of all working towards the same direction, and we're more aligned. And so safety culture also comes in with it. It's sort of breaking down the silos that, production's in one silo and quality's in one silo and safety's in another one. They're much better when they're integrated. You need management support, so not having it is the leading barrier. We probably all live that. And so you need to see, so management, when you measure processes, you have to be able to measure something. And so you need to be able to show this on paper. You need to be able to understand really what are the costs. And it's kind of hard sometimes when we would start talking with these teams of individuals, and you're trying to quantify, okay, well, because you have to do this process this way, how long does it really take? Or how many people does it take? Or if you have a rework, how long does it take? What's the cost involved in the rework? It's not data that's like at the tips of your fingers all the times. So it can take a while, but return on investment includes impacts to production quality and how their profit. So when we started into this, and I'm going to show you the process that we developed and what's in it, and then I'm going to show you a spreadsheet that another student developed, and they're all on the web. But there are tools in existence, and you may have your own tools. These are just some of them, like OSHA Safety Pays and the Washington State and the Cornell University. They usually specialize in pre-project estimates or post. The spreadsheet I'm going to show you does both, which is the beauty of this. This was the work done by, it was an idea that I had, but the work was done by Derek Stevens, who was just a delight to have as a student. So let's go Okay, so now what we're going to do, and I'm looking at my 1233. Okay, I clicked on this link because this is the link to Ohio, to the program that we had. And again, I want to say I had 2 absolutely fabulous graduate students help me on this, and then Derek worked on the cost calculator. Was really, really blessed to have them, and I still see them on LinkedIn, so they're doing well. But what we did was, okay, so the process, sort of the thought process behind this was we wanted to understand how to talk about them, put them into your own system, work them into a Six Sigma project, whatever you might want to do. So very flexible, modular, flexible, and customizable. Okay, so those were 3 things about it that we wanted to be able to do. We started to talk to, and the first thing we did is we just started to talk to individuals in manufacturing, like, what are the barriers to this? What do you need? And we got the ideas for the tools from all of our discussions with industry. So, and so when we went out, we did it that way. There are tools, all of these tools are on here. So what you see is, I'm going to click on this and I'm going to hope that this link is still valid. Yeah, so this is the final binder that had all of our PowerPoints in it. It has all of the training documents, you know, everything's in this. So if you want to use this, you can use, it's like an introduction presentation with all the tools. But what we did was, we developed these tools, so like a process map tool. So the process map was one that we looked at. And this, again, these are meant to be done in groups, and they were pre and post. So starting the product, finishing, description of the task, a picture of it. So this is like what is going on with productivity concerns, safety concerns, and they were just all listed. So what you had to do is, it's sort of like not a value stream, but think about, I have these multiple steps in the process and what goes on, and having people together talking about them. So each of these tools, like the process map, you have instructions, you have the actual Excel sheet and an example, and a PowerPoint that goes with it. Then the next thing was a prioritization tool. So just like anything else that you'd go through, the first thing, like, we would go out to the companies, we would do the process map, we would say, okay, what are the different things going on? And then we would evaluate them. And this is sort of based on an FMEA. And so what you can see is it has severity. So the department, the potential injuries, and a severity rating and a productivity risk rating. And then, so it was like the characterization, you got this score, just like you would get on FMEA, you'd get an RPN, a risk priority number, you get a priority score, and then you'd go and you'd put your activation in and you'd have your results. So the second step in this process that we developed was prioritization. And the one thing that came across, that some of the, you know, in the notes from this, it gives you some ideas about what's the different scoring features, or how you would rank things. But what it's really asking people to do is, first you think about all the processes together and the safety and the productivity and the quality. Then you try to prioritize, okay, which one should I do first? So it gives you a roadmap for what you want to do. I had one person who I really miss seeing him a lot. I used to work with him a lot, but he used to always say he was a safety manager. He had a safety committee. He wanted things that they could do, not just like come together and talk about what's wrong. So the prioritization really gave them, you could develop like a year schedule based on that, what you wanted to do. Then a mod VSSM is a modular value stream safety map, and it enables you to go in and look at the person, look at the, not the person, but the particular tool. So, and these are just Excel sheets, you know, you can change them, you can modify them. But you give the current state, the task description, then the future plan, productivity, and these should be productivity. It means productivity and improvement, quality. And then you could give it pre-state and post-state. You can give it a color code. So you can say, okay, like here's the here's the picture, here's what's wrong. We went in and we did this, these were the concerns. And then afterwards, here's what we did. Maybe there's still a little bit of a concern here on this one, but 2 and 3 are, and then you always put like the responsible person and the due date. But so you had a mapping, and again, these were sheets. You can customize them, you can make them one sheets, throw them into a presentation, whatever you want to do. And then process training, this is just a template for training. I'm not going to go too much into this. And then we had these 2 other tools in here that we didn't call them core tools, but safety requirements, Poka-Yoke. So Poka-Yoke means mistake proofing. And this really came up with one of our companies who said that they had these great, like super duper, superstar lean people, but sometimes they would have lean, you know, events and changes and redesigns, and they didn't really consider all the safety. So it was just trying to have a tool that you could go through just some basics. These are just some basic safety factors, and you could change all these based on yours. But you know, what's being moved and where, how does it affect production? How does it affect safety? Just getting everything on the table about it. I really think that probably, and we heard this through our evaluation, is that the communication aspect of this was key. It just because you have to do it in a group like a Six Sigma project, and you have to bring in the different types of people who are involved, like a person working on the line, a supervisor, a maintenance person, the safety person, and just gets you talking. And then distractions, again, and these were all, like I said, these were all ideas brought from our people working in the companies. But we just had some companies who really said that they had some issues related to distraction in the workplace. And so it was a tool related to distraction and fixing that. And then just the summary. But the one thing I want to show you in more detail is this cost calculator was developed by Derek Stevens. And I have to. Okay. I'm going to bring this up and talk a little bit more, and then I can answer any questions. This what you're seeing now is on the website too. And he, like I said, all 3, the 2 students who worked on it, and then Derek, wonderful students. And he was obviously super into Excel, but he was also engineering technology and management undergrad. So he had a good sense of rework and scrap and production times and things like that, more so than someone who didn't have that kind of exposure. So what he did basically is his idea was that if you're working through this process, like anything else in life, like you have to do something once and you do so well, and then if you do it again, you do it again, you do it again, you start to get better at it. And so what a lot of the cost tools that were out there were like, okay, here's some estimate of what we might save if we do this, or here's what we saved when we did it, you know, like, but they didn't really have a way to combine both of them, so that if you were really trying as a company to move towards this goal of proactive design, integrating safety, there wasn't really a tool that, you know, there could probably proprietary tools that you pay for, but there wasn't a tool out there. So we had, what he did was you do this for a particular intervention, right? So you write in how many employees, the wage, direct costs, size and everything. And then you have to put these other things in. You notice that there's terminology over here, but these all go into calculations, like how many hours are on the shift, what's the cycle time, overload needed. This is a current cost calculation. Have you had accidents or incidents, if you want to refer to them as that? Shifts in the day. This is just characteristics, right? So, and then these are related. So the types of injury you can put in. Okay, so what he did was he went in, these are different kinds of injuries, and then depending on what you put in, it can change things, different costs. If I put one of those in, it adds that. This is not, you can change these numbers. So if you had cost yourself and you knew what they were, you could just go in and there's a, you can see there's a page that has these costs that are referred to. So you can change that. Yeah, so that's the first page. And then what you do when you think about this is you have quality, like what's involved with quality and failure costs and costs associated with the interventions. So the cost of materials and labor and everything, any other time costs. And what the impact will be. So, and this is a pull down menu because this is using a calculation factor, but what you think that the change will be. So basically the first page is like collecting all this information about, okay, who's working on it, what kind of injury, if you've had one, what's the cycle time, how much time is on the shift, and different kinds of costs. And then what it does is it goes in and it will, you can see I have this one data point in there, but it will go in the second one and it'll say the cost of the intervention. And then it'll say projected work-related musculoskeletal disorders after the interventions. And you can do cost avoidance too. So I haven't even talked about that, but you know, there's this, we all know there's cost avoidance and cost savings. Cost avoidance is great, but it's not hard money. You know, it's something you might do, might save based upon the fact that you're hopefully not going to have the back injury you had last year. But there were savings due to hard savings due to process changes, right? Like I don't have overtime, I don't have rework, or there's potential savings due to no injuries. And then you go back in and you put in your post. So then you project this in the initial thing, you go do it, and then you come back and you put in your what actually happened when you were out there. And again, it's gonna, so the first one is pre and the second one is post. And then what it does is it gives you differences. So the current cost, previously projected, what's the difference of it? And the idea behind doing this, being able to compare on a spreadsheet between pre and post, was the idea that if you did it more and more, you'd get better at it. So we would expect a fairly large variance initially, because you know, it's just like anything else, you're trying to learn how to do this, you're trying to learn how to estimate these costs and what's going to happen. But as you would repeat, you would get better and your estimates would get better. So it would also be good, like if you were doing reports to your supervisor, because you could say, okay, we're working towards this really proactive way of looking at things, and we started doing this, and initially, you know, this is the process, we estimated this, here's what we found. But as we did a couple of these interventions, we found that we were much better, lower variance, lower difference between pre and post. And you can use it in your reports or whatever you do. And you can also, like, there could be things that you miss. So like maybe initially you you're underestimated maybe scrap or something. And then when you did it, you start to get a better idea of that. So that was this was his spreadsheet, and it was just a really great, you know, like I said, he did a really great job on that. So that's on here. There's a guide in the tool. That's just progress summaries, just reporting on it. So these were this is what we did. We got to the point for this. We developed the products. We were able to write an article on it. We were not able to write a longer article on it. So we were not able to write like a like a 1 month, or not a 1 month, a 1 year use of this tool to see how it helped. So in my back of my mind, I'm always thinking like it would be really great to have some companies on board that would be willing to help to do that. I just have a couple, and then I'm going to be open for questions. So these are just things here at Liberty. We're always looking for collaboration, research projects, capstone, summer internships, or plant tours. It's funny how this automatically put a little plant there. And that's my email. So Ogaga, that's what I have for today.
All right. Thank you so much, Dr. Schwaha, for sharing your research with us. That was a great presentation. I enjoyed it. So we're going to turn it out to questions. So if you have any questions for Dr. Schwaha, please type them on the chat window. Or if you want to speak, you can go ahead and unmute yourself and speak directly. So we still have like 10 minutes. Any question?
Oh no, I don't think that's good.
Not really.
How many people, I'm just curious, like how many people do integrated looking at safety with productivity and quality all together?
Okay, so we have a question. Anyone wants to respond? Do we have anyone in attendance that does something so related that want to share their experience? The quiet day.
Thanksgiving is in 2 weeks.
I know.
Everyone
it's so
is
quiet.
Like waiting for the break. I know.
Yeah, but I mean, I think we have a comment from Horace. Let me pull that up. Try to weave it in with SOPs and JSAs. Okay. Quality and safety.
Totally agree. Especially the SOP. When you are in that, like doing the value stream safety mapping, that's a great point at which to bring in your SOP with that and look at it, or a JSA, especially the JSA when you're redoing the task. So look at it, and then when you do the intervention, go back in and redo your GSA.
That's good. Thanks, Horace, for your comments. I remember there was a time when I did my internship, at Cummins. Cummins is big into industrial engineering, and they do a lot of Lean and Six Sigma process improvement. So some of the tools that you showed, I think they have something comparable that they use in-house to like develop their process and all that. So one thing I'm thinking is that as far as the Lean technology is concerned, one of the citation you have there indicates that sometimes it creates a lot of repetitiveness for those who work in or who are involved in the process. So what about Lean that is automated so that workers are not directly involved in it? Is that something?
That wouldn't apply then.
Okay.
Yeah, it wouldn't apply. If it was automated, it's just the factor of if you lean things out and you make if you lean things to the point that you're increasing cycle times a lot, that can be worse for the person. Automation, I think, can be healthy. It's again like what you're automating and what part of the process, and then how that's related to the other parts of the process.
And I can add to that.
Okay.
So My name's Holly Pups. I'm a former OSHA compliance officer, but I've also worked in quite a bit of manufacturing. And so I've worked in facilities where they've had extreme lean practices, but the lean and the safety team were tied together. So none of those new processes or new automation were conducted without implementing the human factor first. And it was a really successful safety program. But it was a conjunctive effort instead of, as you mentioned earlier in the presentation, getting safety to sign off at the last minute. So it was really interesting leaving that environment and going to one where lean was an idea that they didn't really want to implement either. But that cohesiveness between those who are doing these minimizing efforts do need to have that people focus. Otherwise, it's not going to be successful, and you add all kinds of other concerns to the people factor and take it away from the machine, which defeats the purpose of having the machine.
Yeah.
Yeah,
Good. Great.
thanks. Great comments. Okay, Horace has something else on the charts. Let me see that. Automation is good, but then have to ensure machine guarding and ergonomics for the equipment and interface. Agree. All right, any other comments or question? I don't see anything. Well, thanks again, Dr. Schwaha. And we hope you're going to share your presentation with us so we can post it on our website. I really like the tool, the last cost estimate that you showed. So that's really a good resource. I'm going to look up that and try to play with it as well on my own. See how I can work with it. I believe it's free because
It is
it's
free.
on the
It's all
website.
posted. So there's a link to the Ohio site. Everything is on there.
Okay, I figured. All right, so for our attendees, we have a few announcements. So next month, we're going to be having an end of year social. So more info to come on that. You're going to receive communications directly to your email. So watch out for that. So we'll not have like a formal technical meeting for December. So take note of that. We look forward to seeing you all. So please, when you get the information, we encourage you to sign up. It will have the detail, the venue, the time, and all that. I can confirm that it's December the 16th, but other than that, you get the information about the venue and the time. So watch out for that. And please, if we don't have your email, we encourage you to put in your email on the chat window so we can send you the certificate for this technical meeting. So get those up on the chat window, please. We encourage you to do that. I think those are the announcements that we have. If there is anything that I omitted, if there's any EC member that may want to call my attention so we can announce that to the House. Other than that, Dr. Schwaha, do you have any final comments for us?
You know what? Thank you for inviting me to talk. We're not that far. I think we're about 3 hours from you. So if you ever if you'd like to collaborate on anything, you have my email. I'll send Ogaga the presentation, and yeah, no, just hopefully I can meet some of you in person. The conference that's done in September at the beach, it's so, I mean, I would love to go, but it's just the worst time for me on the academic schedule.
Okay.
It's right at the beginning of school, so it's just hard, but hopefully I'll meet everyone.
One thing I will tell you though, and this will also benefit attendees, the regional conference next year is going to be at the beach in South Carolina, but in 2025 it's going to be in Virginia Beach. So we're trying to take it over to there. So it's not going to be in Myrtle Beach, South Carolina. So maybe, who knows, you may have that flexibility to attend. So we'll look up to that. And we look forward to collaborating, anyway. I saw your last slide on our internship opportunity. I think we sent one out. I don't know if you got the communication that I sent on internship.
I did.
Yeah.
Yeah.
So as soon as I receive
I
those for
shared
the
that.
region, I'll be sharing them with you.
Okay.
All right, thank you so much. Thanks all. We will see you at the social for those of you that can make it there. Until then, be safe, take care, and bye for now.
Bye.
Bye.